Now I'm going to introduce you to the chain rule in multivariable calculus. This is nowhere near a proof. It's me merely oversimplifying the whole situation in the hope that you would understand the chain rule when it comes to multivariable calculus. So let's say you've got this scenario here where x and y are driven in terms of a new variable. Let's imagine this new variable as being time. So what's going on here is, for a given time, it will then tell you the location, the x location of the particle and the y location of the particle. So what that means is this. So our scenario is this at the moment. So what that means is, for a given time, let's imagine 2 seconds. 1, 2. So after 2 seconds, the particle will be at an x location of 6. So that means it's 1, 2, 3, 4, 5, 6. And after 2 seconds, the location of our particle will be at 8 in the y direction. So it's 1, 2, 3, 4, 5, 6, 7, 8. Let's imagine it's here. So currently it's at a location of 6, 8 after 2 seconds. So remember, x and y represents our domain plane. It just represents our domain. So when you put 6 and 8 into a function, when you put 6 and 8 into a function, it will then jump to a height of w. It will then jump. So when you put 6 and 8 into a function, it will then jump to a height of w. So let's just imagine this has a height of 10. Let's just imagine this. So the chain rule says this: if you want to work out dw by dt, so dw by dt, what this means is this: dw is a change in the height. So in our case, after 2 seconds, it will have a height of 10, and this change in time, in our case, the change in time is 2 seconds. So if you want to know this gradient quantity here, then simply work out the partial derivative with respect to x and then multiply it by dx by dt. In our case, dx by dt is you simply differentiating this equals 3. So you would put this 3 into here, and if you look at the y, dy by dt equals 4, so you would put the 4 into here, into here. So you would put the 3 in here and put a 4 in here, because what this means is, after a unit of time, it would have moved 4 across in the y direction, and after a unit of time, it would have moved 3 across in the x direction. And when you come to compute this, remember, we've done this before. This thing here means you have to imagine a vertical sheet of paper in the x direction, and then you taking the partial derivative, and this thing here with respect to y, in your mind you have to visualize a vertical sheet of paper in the y direction, take the partial derivative, and then multiply it by dy by dt. So let me elaborate on this even further. Let me elaborate on this. Hang on. But before I do, I need you to realize that. So going back to high school, an equation of a straight line is given by mx plus c. Let's just look at one scenario where we've got a line of gradient 3, say. So this has a gradient of 3. So this line here is y equals 3x, this line here. I need you to realize that when you know the gradient, if you times it by the across, let's say the across is 2, if you times it by the across, then it will give you a height of 6. So if you know a gradient, bear this in mind, if you know the gradient and then you times it by the across, then it will then give you the height. Just bear this in mind. I need you to know this. So let me just let's have a look at this scenario here. Let's say you've got a paraboloid. So instead of being straight up, it's slanted slightly in this direction. So this is our paraboloid. This is our paraboloid. When you compute this thing here, so when you compute this thing here, it's really you looking at a vertical sheet of paper in the x direction. So imagine you've got a vertical sheet of paper here. When you compute this thing here, hang on. When you compute this thing here, this thing here is really the intersection of our surface with our vertical sheet of paper. So let's just say the intersection is right here. It looks something like this. Okay, let's just imagine it looks something like this. Oops. Let's just imagine it looks something like this on our vertical sheet of paper. This thing here allows you to work out the gradient. So imagine this as being the steepness in the x direction. Well, dx by dt represents the movement in the x direction. So after 2 seconds, after 2 seconds, you would have moved across by 6. So what that means is 1, 2, 3, 4, 5, 6. You would have moved across. Well, here you know the gradient, and here you know the width. So when you get one thing multiplying another thing, it will then give you a height. It will then give you a height. It will then give you a rough height. Let's imagine this height to be 4. And then looking at it in the y direction. So when you look at this thing here in the y direction, you've got to picture a vertical sheet of paper in the y direction. So let's just say it in the sheet intersects the surface right here. So it will look something like this. So when you look at this thing here, it represents the gradient. So imagine the gradient as being like this. Imagine. So this thing here is our gradient. So when you look at the dy by dt, after 2 seconds, 1, 2, it would have moved across by 8. So it would have moved across by 8. So 1, 2, 3, 4, 5, 6, 7, 8. Let's just say this is 8. If you know the gradient, and then you times it by the width, then it will then give you the height. Let's just imagine a height of 6. So hang on. So looking at this thing here, hang on. After 2 seconds, 1, 2, you would have moved across by 6. 1, 2, 3, 4, 5, 6. You would have moved across in the y direction by 8. So you would jump to a height of, let's say, 10. Imagine you're an ant having to move from here up to here. You have to move in the x direction by 6, in the y direction by 8, in order to get to here. So wait there. Earlier we computed that in your journey in the x direction, you've moved across by 6, and then you climbed a height of 4 earlier. You climbed a height of 4, and then in your journey to get from here to here, you would have to move across by 8 in the y direction. So in your journey of moving across by 8, you would have climbed a further height of 6. So what that means is this 4 here, in your journey of you moving in the x direction of 4, sorry, in the x direction of 6, because of this thing here, after 2 seconds you would have moved across by 6. So you would have moved across by 6. You would have climbed a height of 4. So this whole thing here, you would have climbed a height of 4, and then you would have to move across in the y direction by 8. So in your journey to move across by 8 in the y direction, you would have climbed a height of 6. So this here represents our 6. So the change in the height would be 10. You would have climbed a height of 10 in a period of time of 2 seconds, 1, 2. So I hope you understand what's going on. It's just, well, this thing here gives us the gradient. This thing here tells us the width of, let's say, 6. So when you know the gradient, and then you multiply it by the cross, it will give you a height, roughly speaking, a height of 4. And then looking at this thing here, you know the gradient. When you times it by the cross, in our case, is 8 here. If you know the gradient, and then you times by the cross of 8 in the y direction, it will give you a height of, let's say, 6. So So combining the two, you climbed a height of 4 in your journey moving across in the x direction, and then you climbed a height of 6 on your way as you move across in the y direction. Then in total the change in height is 10. It's just me badly explained this, but I hope you can understand what's going on here. And by the way, at this moment in time, you don't fully understand what dw by dt really means. In the future, I will give you more examples, and hopefully you will understand. But at the moment, just have a rough understanding that we are just merely computing this value here. You don't fully understand what dw by dt really means yet, until I give you more examples. Okay.